Hi students, I hope all of you had good health. So after vacation, this is our first class we are doing, and we will be beginning with the lesson metal and non-metals. Though the chapter is already known to you, again the same concepts are being repeated over here. Now we will be learning about metals and non-metals in details, then about their applications in our daily life and so on. First of all, elements. These elements we can divide into two broad groups, that is metals and non-metals, and apart from this we have two more groups, that is metalloid and inert gases. Okay, now we will be beginning with the characteristics and occurrence of metals, and then we will be learning about the characteristics and occurrence of non-metal. Then at the end, we will be drawing a difference between the characteristics that we will be learning now between these metals and non-metals. Now metals, it occurs in both free and combined state. Like gold and platinum are exclusively found in free state because they are not reactive. That is why students generally the jewelries we make are mainly made up of gold and platinum. Why? Because they are exclusively unreactive in nature, and that therefore whatever jewelries we make, it will remain as it is. There will be no rusting or reaction with other components so present around, and therefore gold and platinum is very much costly also. Next, copper, silver, mercury occur in combined state due to their low reactivity. Now, though we use silver also as jewelry material, but sometimes if you ever go to a shop, you will see that the cost of silver is much less than gold and platinum. Why? Because they are reactive to some extent, and they form compounds of other substances also. So they generally occur in combined state. Next, most of the metals are found in combined state. Why? Because they have high reactivity with other substances around. Like we have already gone through our practical video lesson where we have seen that when sodium comes in direct contact with water, it instantly catches fire. But you put your one of the jewelry material made up of gold in water, you will see nothing happens, no reactivity occurs. Then why sodium instantly reacts with water and catches fire? And the question is, and the answer is that sodium, potassium, magnesium, all these metals are highly reactive, and therefore most of them are found in the combined state due to their high reactivity. Next is, here are some of the properties of metal. What are those? Let us see. First of all, metals are ductile, malleable, good conductors of electricity, good conductors of heat. It is shiny with high melting and boiling point, and also the density is high along with the strength too. Now all these characters which I have written down over here as different points, I will be explaining you all one by one. So let us begin. Now, ductility. What is the meaning of ductility? Ductility means it's a characteristics property of metal by which they can be drawn into wire as the picture shown over here, that this is the copper metal which is drawn into wire like this, and even in your home electric circuit also you will see that the wires inside are made up of copper wire, and above the copper wire a plastic covering is there, so that the entire circuit becomes non-conducting. Suppose you touch the component with your hand also, the wire, you will not catch electricity. Why? Because they are made up of copper, but they are coated with a plastic covering. So then ductility means they can be drawn into wire. For example, other than copper, gold, silver, aluminium, tungsten are the most ductile metals. Next is malleability. Malleability means, students, they can be beaten into sheets without breaking. Over here, I have shown you a diagram of gold, and if you use hammer like this, it can be beaten into sheets like this. And from here only, the jewelries are being made. So, what can we draw conclusion from here is metals like gold and then platinum, they are highly malleable. They can be beaten into sheets for various purposes. But there is an exception too, like zinc. Zinc is not at all brittle. On beating it, it breaks into pieces. So students, don't forget to learn about the exceptions also in question, in paper in questions from the for the exam, for the first terminal, for sorry rather the second terminal, the questions may be asked from this exception part also. So be aware of this, and do learn the exceptions of different properties which are being stated over here. Next is metals are good conductors of heat and electricity. One of the very common example which I have shown over here, student, is suppose you have taken two spoon. One is made up of plastic and another made up of a metal. If you dip both the spoon inside a very hot water, you will be just holding the ends of the spoon tightly, you will see that after some time the plastic spoon will remain as it is, means it will remain cold and as it was, or at normal temperature as it was. But when you are holding the metal spoon, students, you will see the heat energy reaches to this end, and you start feeling the hot sensation in your fingertips. So from here we can conclude that metals are very good conductors of heat. Therefore, when you dip the spoon inside, the plastic spoon remains as it is, but the metal spoon becomes hot. Next, over here I have shown another diagram where the copper wire is being turned around this battery terminal. One end is connected to this metallic part, and another to the bulb. You will see when you switch on this circuit, the bulb will start glowing. This shows that electricity very easily flows through where? Through this circuit. But when you just coil this wire around this plastic part of the screwdriver, you will see the bulb will not glow. Why? Because this plastic part will not act as a conductor of electricity. So from here we can conclude that metals are very good conductor of heat as well as electricity. Next is and another example is also there where metals are not at all a very good conductors of heat and electricity is tungsten and lead. This tungsten and lead are very poor conductor of this heat and electricity. That is why inside the glowing bulb we use the tungsten filament so that it doesn't catches electricity or the heat energy doesn't melts it. That is why inside the bulb we use the tungsten filament for its glowing. Next is metals are shiny. Over here, the various kind of metals, I have pasted it as the picture in my slide, where it shows that be it brass, be it aluminium, be it cast iron, copper, steel, bronze, whatever it is, they are very much shiny, lustrous. Okay. Means whenever they will be polished properly, they will glow, immensely glow. But there is an exception too, like lead is a dull metal. It will not show any luster. Okay. Next is metals have high melting and boiling point. Now students, melting and boiling point, all of you know. Melting point is the point when a substance starts freezing, and boiling point is the point at which substance starts converting it into its vapor form. Now metals have high melting and boiling point. You have often seen in some of the uh, television channel that while making sword or any item from this metal components, uh, we need to heat it very properly, and then we need to shape it properly, and it will be shaped properly only when the metals are heated to a very high temperature. So over here, like this, the picture which is being shown over here, it should be red hot like this. Then only it will be we will be able to heat it and give just heat it with hammer, and then we can give it proper shape. So from here we can conclude that metals have high boiling point and melting point, and this is very much because of very strong intermolecular force of attraction, and it needs a lot of energy to melt or to boil. Okay. Like I have given some exception over here, though this two exception is not given in your book, dear students, but still I have given to you this one in I have provided the information to you all over here, so that you get this extra knowledge with you. Next, this one is rhenium. Rhenium has high melting point, whereas tungsten has high boiling point. You can note it down in your own record, though this one is a little bit, this two example is out of the components which are given in your book, but still I have included the information over here for your understanding. Next is occurrence of non-metal. Now students, whatever characteristics which I discussed above, non-metals exactly have the reverse of all the this components. Okay. Like non-metals are generally not so much lustrous. Okay. It is not at all ductile and malleable. It is a very poor conductor of heat and electricity. These are the conditions or characteristics of metal which is totally in opposite way with respect to metal. Now non-metals occur in earth's crust in combined state as oxides, that means in combination with oxygen. It may be carbonates in combination with carbon dioxide. It may be sulfates, that is combination of sulfur dioxide, or in combination with nitrogen dioxide to form nitrates. Okay, this is because generally nonmetals are highly reactive. Now in atmosphere, both in free state it may occur as oxygen and nitrogen, or it may occur in combined state also as carbon dioxide and water. Next, the most abundant non-metal in Earth's crust is oxygen, whereas nitrogen forms 78% of the air in free state and is the most abundant element of air. Remember these 2 points, students. If the question is asked that the most abundant non-metal in Earth's crust, it will be oxygen. And if the question is asked the most abundant element of air, then the answer will be nitrogen. These things needs to be kept in mind. Now here is a comparison study between the metal and non-metals, how they differ from each other or what are the basic difference between them. First one is, as I stated, that metals are good conductors of heat and electricity. Okay, whereas non-metals, they are very bad conductors of electricity. Though there is some exception also to this, like carbon in the form of graphite. Okay, they conducts heat and electricity very well. So as I am telling you repeatedly, you need to read about the exceptions also. So graphite, which is a form of carbon, is a very good conductor of heat and electricity. But in other cases, apart from this exception, non-metals are very bad conductors of heat and electricity. Next is, metals can be beaten into sheet. That is, they are malleable. But non-metals are not malleable. But there is again one exception to this is carbon fiber. Carbon fiber is one of the form of carbon that is a non-metal which are ductile. So this exception needs to be learned. Next is metals are malleable. Sorry, metals are ductile. That is, they can be drawn into wire, as I have already shown you in the pictures in my last slide, that metals are generally ductile, whereas non-metals are not at all ductile. For example, again, carbon fiber, which is not at all, which is again very much ductile. Next is metals are sonorous. Sonorous means while we clink, just we hit it or clink it, it will produce sound. Okay, but non-metals are non-sonorous, means it do not produce any sound when struck. Metals have high tensile strength. Tensile strength means if you try to tear aluminium wire or copper wire very easily, it will not undergo the tear and wire action. Why? Because as I said that it has high intermolecular force of attraction and low intermolecular space. Therefore, the molecules are very tightly packed, and therefore the tensile strength is very, very high. But there is an exception to it, that is zinc. Whereas in case of non-metal, they have low tensile strength due to low intermolecular force of attraction. But there is an exception to this, that is carbon fiber. Next, metals have high density. That is also the same reason, that is, it has high intermolecular force of attraction and low intermolecular space between them, whereas non-metals have low density. Okay, density in this case is very high and low. But there is an exception to this is, in case of metal, sodium, potassium has very low density. They are even lighter than water. If you try to just dip sodium inside water, you will see it remains floating in water and catches fire. So this is an exception, and if you try to cut it with the help of a knife, you can easily do it. So they are soft metal. They do not have high density, whereas non-metals have low density. Again, the exception is iodine, diamond. They have high density. Dear students, don't forget to learn about the exceptions. I am telling you repeatedly, these are very important. Next is, metals have high melting and boiling point, whereas non-metals have low melting and boiling point. Next, metals combine with oxygen to form basic oxides, whereas non-metal combine with oxygen to form acidic oxide. Okay. though you have not learned about acid and bases, but you can just learn about the last point which I have provided in the slide is not so much important for the exam as it is not there in the book, but for your additional knowledge I have added the last point over here, students. Okay, next, apart from this, I am just telling you some few more points which can be included over here. That is physical state. Metals are generally solid at room temperature. Exception is mercury, gallium, and where non-metal is exist in all the three states, like oxygen, nitrogen are gases, bromine is liquid, while phosphorus, sulfur, carbon are solid. These are the difference based on physical state. Next, alloy formation. Metals combine with other metals to form useful homogeneous mixtures called alloy, whereas non-metal do not form alloy. Solubility. Metals are insoluble in water and other organic solvent, whereas non-metals can be soluble or insoluble in water or other solvents. So these are the basic difference between metals and non-metals. Next is corrosion in metal. Most of the metals, when exposed to atmosphere, react with moist air and get corroded, to which their properties are destroyed and their use as metal diminishes. Okay, so this is one of the problem which we face while we are using or handling substances made up of metal. That is due to its high reactivity with air. It forms some other component, and the utility of the substance which we made from this metals will get diminished. So this happens because metals are reactive, and due to their reaction with moisture, they change into more stable compound. As we have already learned during that chemical reaction part, that most of the substances or elements try to attain stability, and how they try to attain stability by forming chemical compounds by combining with other components, like it may be an element, it may be a compound. And this occurs how, students? I explained you that by means of either gaining or losing electron or sharing electron. Okay, last time we read about this and about the valency also. So based on that concept, I am explaining this, that this happens because metals are reactive, and due to their reaction with moisture, they change into more stable compounds. Next, aluminium reacts with air to produce aluminium oxide. These are the example, because it has high affinity for oxygen. Next, copper forms a green deposit of copper carbonate when exposed to moisture. Again, lead forms white deposit of lead carbonate when exposed to moist air. Now, these are some of the examples which I have cited over here so that you can understand what is the meaning of corrosion. Corrosion means, again, it is the formation of a new component of a metal with another when exposed to air, and as a result the substance which is made from this metals for our utility gets diminished. One of such example of corrosion of metal is rusting of iron. The picture which I have provided over here is a very known phenomena to you all, students. As you can see, this is the newly made chains of metal which immediately turned like this. It formed rust like this and it is rendered useless. Okay, now rusting is a slow oxidation process in which iron slowly reacts with oxygen in presence of oxygen of air in presence of moisture, and produces a flaky brown substance called rust. So this is the definition for rusting. Now the next question is, what are the different conditions which are required for rusting? Means how does it occur? Now, generally what happens when this chain of iron comes in contact with air and also in contact with water vapor or moisture or directly water, what happens? They together reacts with each other like this, and they form a iron oxide. That is, over here I have given the chemical equation, that is 4Fe plus 3O2 plus 2H2O gives 2Fe2O3 dot H2O. This is the chemical formula for rust. And when this flaky brown substance is formed and it gets deposited on this chain, it what happens, the chain is rendered useless, we cannot use it anymore. And this is a very common phenomena which occurs in our day-to-day life. Now the question is, next is next we will be learning that how can we prevent this rusting, because it will create a hazardous situation. Now there are various techniques by which we can prevent rusting from occurring. First of all, painting with red lead. Okay, first picture which I have provided over here, it shows the painting with red lead. Now when you are painting the iron substances, whatever it is, with red lead or oil painting or whatever, what happens, the contact of the substance with the external oxygen in the atmosphere gets cut off. Now whenever this get cut off, what happens, there will be no rust formation. Why? Because in my previous slide I explained you that both oxygen, moisture are one of the essential component which is required for rusting. Okay, that is why these are done, that is painting with red lead, oil painting or enamel coating, greasing, whatever you see, it is mainly done to prevent the contact of oxygen with this substance. Next is enamel coating. Now you have often seen this non-stick frying pan or any utensils like this. Now the inside of this utensils are coated with enamel so that it do not come in contact with oxygen and it is prevented from rusting. Greasing you have often seen that in cycle or other parts. Okay, oil is being applied. Now when oil is being applied in these parts, what happen, rusting is prevented in that case. Apart from this, there are other techniques like galvanization. Now what is galvanization? It is simply a process by which iron articles are dipped in molten zinc. Okay, like over here you can see steel is over here. Now we will this steel is dipped in melted zinc at 460 degrees Celsius, and this galvanized steel is again formed. Now when galvanized steel is formed, it will prevent the steel component to come in contact with the moisture, heavy moisture, and as a result no rust formation takes place. Next is, apart from this, tin plating is here. You can see this parts or different parts which you see around you, like the this iron nails and all, they are generally tin plated. We have alloy formation, another technique, like the coins which use in our day-to-day life, it is made up of alloy of different substances or aeroplane parts, and so many components are there which are like duralumin, one of the alloy which is used for aeroplane making aeroplane parts. They are mainly made so that it do not form any so that this rust formation do not take place. And the last is the electroplating. Okay, now iron articles are electroplated with copper, chromium, tin, nickel for decorative purposes in jewelry and for durability of cutlery, cooking gas stoves, motor parts, etc. But it is a costly process. An alloy formation, as I said you, by this process iron is fused with nickel, chromium, carbon to form stainless steel. okay, which is a lustrous corrosion resistant substance. It is used for making cutlery, surgical instruments, and so on. Apart from this, another technique is there, that is aluminium plate painting. This process protects iron bridges, iron furniture, car bodies, telephone poles, etc. from rusting. So these are the different uh, examples or different ways by which we can prevent rusting from occurring, and this is the topic which we will be learning up to today. I hope you all understood the lesson up to this. Thank you so much, and if you have any doubt, any queries, ask me in my next live session. Thank you.